Continuing with question 52 on our semester review sheet, we're going to practice inverse trig functions, and it's important that we remember the restrictions, and you can recreate that for yourself if you picture the sine function. You can always say, oh, remember that the inverse is restricted to this 1-to-1 section from a minimum to a maximum. So when we're looking for the arc sine of negative square root of 2 over 2, we know we want to look between negative pi over 2 and positive pi over 2 on the unit circle. So we're saying what angle has this value as its sine, and I hope you recognize that as the leg of a 45-45, and since it's negative, we want it to be below the axis. So this would have to be negative pi over 4. Now remember that we could say that 7/4 pi is the same coterminal angle, but 7/4 pi is not within our restriction. So the restriction for the inverse functions is pretty important. Okay, so for inverse cosine then, how do you remember the restriction? Well, picture your cosine wave, and of course then it continues back this way. And what would be the 1-to-1 section where we don't have any repeats on x or y? From a minimum to a maximum, this restriction goes from 0 to pi. So again, you should be able to think why we restricted it to that region. So when you're doing an inverse cosine problem, you're picturing the top half of the unit circle. So from 0 to pi, what angle has a cosine of -1? And of course there's this value here is the only place, so that would be at pi. So inverse tangent, how do we decide what our restriction is? Well, for the inverse tangent function, notice that the section between negative pi over 2 and positive pi over 2 has no repeats. It passes both the vertical line test and the horizontal line test. So our restriction for inverse tangent is the same as our restriction for inverse sine. So again, we're looking for negative pi over 2 up to positive pi over 2. And we want an angle that has a tangent of -1. And that would be, again, our 45-45 triangle where the legs are congruent. So this would be negative pi over 4. Arc cosine of 0, where on the unit circle is the x coordinate equal to 0? And I shouldn't draw the whole unit circle because we just decided that inverse cosine has to be between 0 and pi. So in that section of the unit circle, where is the cosine equal to 0? And that would be at pi over 2. Arc tangent, we just decided that tangent and secant inverses were restricted to negative pi over 2 to positive pi over 2. So where does this come from? This comes from the long leg over the short leg of a 30, 60, 90. So since tangent is y over x, we want the y coordinate to be the long leg, and we want the x coordinate to be the short leg. So we want this 30, 60, 90 triangle, and that would be at negative pi over 3 for our angle. And arc sine, you should recognize that again as the long leg of a 30, 60, 90. So again, these two problems next to each other are referring to the same angle. That would be negative pi over 3, where the long leg is the sine. All right. Now we've got some problems we better think carefully about. Here we're doing the inverse sine of a sine. So mathematically our instinct is to say, well, won't we get right back to 2/3 pi? But remember that that's not within our restricted region for an arc sine problem. Arc sine has to be between negative pi over 2 and positive pi over 2. So we better take this step by step. So we think about angles that have the same sine. So what is the sine of 2/3 pi? Let me do that in red here so we see this is the angle 2/3 pi. So while it's outside of our restricted region, isn't there another angle inside our restricted region that has the same sine value? So in other words, the sine of 2/3 pi is radical 3 over 2. And what other angle has a sine of radical 3 over 2? That would be 1/3 pi. So we're using angles that have the same sine value, but remembering our restrictions, that arc sine, our answer has to stay between negative pi over 2 and positive pi over 2. Okay, so I think we're in business here. This arc tangent, where is the tangent equal to this value? And again, I hope you don't have to write this, but do you recognize that it comes from the short leg to the long leg, y over x? So we're looking for an angle where the y coordinate is the short leg and the x coordinate is the long leg. So we're in quadrant 4 since it's negative. So this would be negative pi over 6. And these unit circle questions, I'm drawing the diagrams. I hope most of you know the unit circle well enough that you can do it more quickly than this. Okay, here we've got a trick. Arc cosine of 3/4. So this is not a 30-60 or a 45-45, but we do recognize it as a 3-4-5 triangle. So we leave the unit circle and we go to SOHCAHTOA. We want to draw an angle that has a cosine of 3 over 4. And that means, and I don't know if I meant to do 3 over 4, I probably meant to do 3 over 5 so that it would be a Pythagorean triple. So let's see if I can draw a triangle so that the adjacent leg is 3 and the hypotenuse is 5. That would make this problem much quicker. So then the tangent of this angle, here's the angle that has a cosine of 3 over 5. The tangent of that angle would be opposite leg over hypotenuse, so that would be 4 over 5. Well, let's say that my typing wasn't an error. What would we do if indeed that was an intentional, where I had the cosine as 3 to 4? Could you still do the problem? Of course. Then the hypotenuse would be 4, and how you would find this leg would be to do Pythagorean theorem. So you would say 3 squared plus a squared is equal to 4 squared. Take 9 away from 16, and we would have the square root of 7 for this side. So could we still come up with an answer? So now we just have a triangle that's not quite so pretty, but what's the tangent of this angle? The tangent would be the opposite leg over the adjacent leg, so square root of 7 over 3. Oh, and as soon as I write that, then I got to go back up here. Did I give the tangent of the angle? I think I gave the sine of this angle. When the cosine was 3 to 5, this leg is 4. I should have found tangent. I should have done opposite leg over adjacent leg. So let's fix my mistake here. Opposite leg 4 to adjacent leg 3. So if I put this as 3 to 5, this is a quick and easy Pythagorean triple. If it's not a Pythagorean triple, then you would do Pythagorean theorem to come up with your answer. All right, let's press on here. So my mistake in that previous question sort of gives you an idea of how to do this problem. We want to draw an angle in standard position that ends up at the point negative 724. So the point negative 724 might be somewhere up here. So the point negative 724, and this would be our angle, but we're going to make this triangle that drops straight down to the x-axis. So what do we know? We know this length is negative 7. We know the y-coordinate is the height of 24. And again, it's a simple Pythagorean triple. I hope you remember that that hypotenuse would be 25. Sorry, that's kind of a small diagram. Okay, so now we're looking for the cotangent of that angle theta. So cotangent is the reciprocal of tangent. In other words, it would be adjacent over opposite. leg. So the adjacent leg would be -7, and the opposite leg would be 24. All right, now we've got sine of theta is 1/4, and tangent is negative. What does that tell us? The sine is positive, so that tells us we're in either quadrant 1 or quadrant 2, where the sine is positive 1/4. And then it says tangent is less than 0, so I think that narrows it down to quadrant 2. So we want to draw an angle that has a sine value of 1/4. How should we do that? Sine is opposite leg over hypotenuse, so I could draw a triangle that has a vertical leg of 1 and a hypotenuse of 4. So do I now have an angle that has a sine of 1/4? So how do we find its cosine? Well, again, we do Pythagorean theorem. So 1 squared plus a squared, you could use any variable there, is equal to 4 squared. So 16 minus 1 is 15. So a is the square root of 15. And once we know that, then we can finish our question using SOHCAHTOA. So the cosine of our angle would be the adjacent leg over the hypotenuse. And our tangent would be the opposite leg over the adjacent leg. And you could rationalize that denominator if you wished. And theta ends up in what quadrant? That would be quadrant 2. Okay, now let me switch colors here and remind you that your textbook suggested an alternate plan here. They had suggested that you go to Pythagorean identity. And this really isn't a different method. You'll see that the Pythagorean identity is the same as using Pythagorean theorem. But we are given the sine is 1/4, so we could square the sine here to get 1/16. So do you see what I mean? That we're going to come up with, for the cosine, 1 minus 1/16 is 15/16, and the cosine of theta turns out to be the square root of 15/4. So, did we do the same thing whether we did Pythagorean theorem or whether we did a Pythagorean identity? Sure. Do you see that the arithmetic is exactly the same? All right, let's see if we got more trig to go here. Solving trig equations. I think because we have 4 of these, I'm going to stop this video and put those in the next one so that you can pick and choose and not have to watch such a long time.